Okay, we saw last time how um, we saw last time in the case of the sample mean of uniform or of normal random variables, we were able to derive the distribution itself as a normal distribution, and then show that for large values of n, the probability that the sample mean is outside the region, outside of a small interval of um, the true mean is very small, especially as n gets large. So we're going to continue with that. That introduced us to the concept of what's called convergence in probability, which we're going to talk about in further detail now in the general case. So convergence in probability. So we have a sequence of random variables. The sequence of random variables converges in probability to a random variable y, so a limiting random variable, y, if, so we denoted by yn converges in probability to y, if for all epsilon bigger than 0, the limit as n goes to infinity of the probability that yn differs from y by more than epsilon is 0. So we know that with very high probability, yn is going to be very close to y for all large n. And this is the concept that we come across, that we deal with when we define what's called the weak law of large numbers. So the weak law of large numbers says that for any sequence IID random variables with mean mu, the sample mean converges in probability to mu, the constant, as n goes to infinity. So this is one of the biggest, one of the most important concepts, theorems in statistics and in probability. We're going to come back next. We can actually prove this theorem, the weak law of large numbers, using the tools that we have in this class. And that's what we're going to talk about in the next video.